for a lot of you, the reason why you're here is this next presentation. I know it's why I'm here. It's the only hour I've known exactly what I was going to be doing for the last, I think, 9 months. I'm really, really excited to introduce Dr. Thomas Insel, the director of the National Institute of Mental Health. Dr. Insel, you won't remember this, but we have met. You told me we were going down an escalator in Baltimore in 2007, and you told me that unless the parent community in the eating disorders world stood up and got organized and did what happened with other fields where parent activism really, really made a difference, that we weren't going to actually get the kind of attention that the whole field needs. And so we did. We are really, really honored to have you here, and we're very interested in what you want to say to us. And then we're going to have a panel with some of the people with the most influence, I believe, on what's happening for our children out there. And we have representatives from organizations that really want to hear from us as a parent community. They've told me that. And I'm sure that they have things to tell us that will be really important. So let's just get started, because this is really exciting and time is tight.
Well, what a pleasure. Thanks, Laura. And it's kind of amazing how this has come together so quickly. I know you've been relentless in making sure what happened. And I didn't remember that conversation, but I'm sure it must have happened, because it is what I have believed for a long time. I've been in this job for 9 years as of next week. And the one thing I have learned over and over again is that for all the things that NIMH does, all the different disorders that we work in, it's often, the progress is often driven not so much by our scientists, which we like to think, but by the families who care deeply and who have, not through voluntary choice, but through kind of happenstance, and have become experts on something that they may have known nothing about years earlier. But these are topics, whether it's anorexia or suicide or autism or whatever of the many things that we deal with at NIMH, that families have had to really learn about. And often they're asking the most salient and difficult questions. So what often drives us at NIMH is making sure we hear those questions in the right way, at the right time, often enough, and that we find a way to respond to them and give answers. So part of what I want to do this afternoon is, I'll talk a little bit. I'm not going to use slides, because I don't think you need that. But I want to make sure that we have enough time for dialogue. We'll have a panel. I won't be able to stay for the whole thing, but we'll have enough time at least for some conversation then. But even before then, I actually come mostly to listen more than to speak, because it's very helpful for me to know about your experiences and your concerns. Let me start by just telling you how, what NIMH is, why I'm here. The National Institute of Mental Health is part of the National Institutes of Health. There are 26 institutes and centers in the NIH. They're part of the federal government, and we are the part of the federal government that is charged with doing research, supporting research for all medical causes. There's a cancer institute, a heart institute, there's an institute for neurological diseases and stroke. Mental illness is a separate institute from the Drug Abuse Institute, which is separate from the Alcohol Institute. So there are lots of these. In aggregate, it's about a $31 billion investment that is all your money. Everything that we do at the NIH is through taxpayer dollars, and it's a federal agency. We're part of the Department of Health and Human Services, so we're in that, part of the cabinet, part of the executive branch. It's separate. That is, NIH is separate from those parts of the government that deal with services like Medicare, Medicaid, SSI, all of those, the Social Security Administration, or even SAMHSA, so which is the Substance Abuse Mental Health Services Administration, which is really important for providing services and especially directing payment in policies through states and communities. We don't do that. We really do the science, and our goal is to do the science that completely changes either the need for services or the quality of services or the impact of services. But the services themselves are paid for, usually through the states, with some guidance and some support from the federal government through this other entity called SAMHSA. So I give you that introduction because people often are people who are in the trenches are concerned about what we can do for them tomorrow, if not yesterday. And what we often are thinking about is a longer-term picture to make sure that somebody is investing in such a way that the big questions like what causes a disorder, what's the absolute best treatment, could we have biomarkers to diagnose much earlier, could we come up with new kinds of therapy, all those sorts of issues are what are right in our wheelhouse. Those are the things that NIMH, as part of NIH, is concerned about. And the way we think about them really it's not that different than the way I would talk to you if I was coming from the Cancer Institute or the Heart Institute. It's really very much the same principles, same problems, and using a lot of the same tools. That's important because as you think about mental illnesses, the way in which we approach them has changed I think, in a really dramatic way over the last decade. And maybe it hasn't changed as much as it still needs to, but it's changing in a way that I think I would argue is probably going to be a revolution. And part of what I wanted to share with you is how I see that. And I'll mention three major changes that I think will have enormous implications ultimately for people with eating disorders, schizophrenia, bipolar disorder, autism, all of the disorders that we're very concerned with at NIMH. The first is to recognize that even though we call these mental illnesses, these are absolutely brain disorders. And that's been a hard problem for people to wrap their brains around, partly because there's been this split over the last century between psychiatry and neurology. And neurology does the real brain disorders like dementias and ALS and multiple sclerosis. And psychiatry does this other stuff, which means that these are behavioral problems. It's the problems of behavioral health, and therefore the appropriate clinicians are not necessarily physicians, and the appropriate tools are going to be the tools of psychology, but not so much biology. And I think that in some ways served us well in the last century, but at a time when biology is going through transformational changes because of the amazing tools of genomics and other things that we have, that doesn't make a lot of sense. We really have to ask ourselves, if these are brain disorders, how do we use the tools of biology that we have to be able to understand them better and to be able to help people who are struggling with these problems? We still use the term mental illness. I'm not sure it continues to serve us well, but we think about these as brain disorders that are a bit different than the kind of classic neurological illnesses. Those neurological illnesses have a lesion, that is, you can take the brain out and you can see a hole in the brain if you have a stroke, or if you have one of these other, like a form of dementia or Parkinson's. There's a group of dead cells. That's not going to be true for the group of disorders that we're concerned with here. Probably not. These are probably more like what we would call circuit problems or functional problems. They're problems in which, while there's not a gross lesion in the brain, you've got an abnormal circuit. Maybe you could even think of these as arrhythmias. Kind of in a comparison with heart disease, you don't have a myocardial infarction, a heart attack where you killed off a section of your heart, but you can have an arrhythmic part of a ventricle, which can be just as lethal, but it requires a different kind of study. And of course, in cardiology, we don't separate out those people who study arrhythmias from those who study heart attacks. That's actually one discipline. We haven't, unfortunately, had that legacy in this field. We tended to separate them. But I think going forward, for us, there'll be a lot of traction to be gained by understanding these as brain disorders. And I say that because we have the tools now to begin to look at the brain, both in people who have these disorders and in people who are at risk, and even in people who have had them and who recovered. And Walt Kay, who's here, has done probably the best work on trying to understand what does happen in the brain when someone develops anorexia, what happens when they recover, and can we understand the circuitry here and why that circuitry isn't working right. I mention this as an important area for us because increasingly we're thinking about using an understanding of circuits to get at the fundamentals, including maybe some new diagnostics so that you could have brain scans that would actually help you to know who's got which disorder. You could use these as targets for new treatments, and that's already happening in areas like the treatment of depression, developing deep brain stimulation, going after areas. We didn't even know the circuitry of that disorder. A decade ago, we now know there are a few nodes in a very complex circuit, and different parts of the circuit subserve different parts of the syndrome. And if you can go in and just change the rhythm of that circuit, you can have people who haven't responded to medication or psychotherapy get better. So as a proof of principle, it looks a lot actually like an arrhythmia, and it looks like the kind of thing that is a different way of approaching this, rather than saying people with depression are a quart low in serotonin, or they have a chemical imbalance, ideas that never really had much support for them. Here we've got ways of actually doing this with a lot more rigor, just as we would in the rest of medicine. So that's, I think, one idea that's really key, is that these are brain disorders. The second is maybe not so surprising when we talk about eating disorders, but it has, I think, been surprising for the broader field of thinking about these illnesses, and that is that these are all developmental disorders. We did a study about a decade ago looking at adults with mental illness across the whole spectrum. This was a large population-based study across 50 states, and it came up with kind of estimates of the prevalence of many, many different kinds of illnesses. But what was striking about it was that people who had a mental disorder as adults, when they talked about onset, 50% of them said they had onset of symptoms by age 14, and 75% by age 25, 24. So that's just strikingly different from the rest of medicine, cancer, heart disease, stroke, dementia, I mean any other part of medicine you want to look at. These are really the disorders of young people, and that's important for several reasons. One is that it means that you've got potentially a very expensive and chronic disability if people don't get better. A second is that you've got a problem that of having a brain disorder emerge at the same time that the brain is still developing. We now understand that many of these circuits don't actually mature until your early 20s. So if you develop anorexia at age 13, you have to ask, what impact does that have on a process that's ongoing? And we just haven't thought well enough about that. But there's another way in which I think this is probably more important to consider as developmental. When you talk about developmental disorders and you think about cause, you think not so much about what happened, but when it happened. It really does matter where in a trajectory the events take place. And why I stress this is because increasingly we've begun to, across medicine, we've begun to think about illnesses along trajectories. And we've begun to understand that for other brain disorders like Parkinson's or Huntington's, these kind of neurodegenerative disorders, the symptoms that we know about, which are usually motor symptoms, are the last thing to happen. That actually behavioral and cognitive changes happen very late in any process that involves a brain problem. The brain is very good at preserving function. I mean, it is wired through evolution to be able to preserve behavior and cognition, behavior and other kinds of function, to make sure that people continue to be adaptive and survive. By the time you have the psychosis of schizophrenia, or the mania of bipolar disorder, or the severe stage of anorexia, it's likely that that's, in some ways, a late stage of a long developmental process that we just haven't known nearly enough about. Now, I say this because we have known for a long time that in medicine, whether it's cancer or heart disease, if we get to the event, if we get to the person at a late stage, we often don't do very well. And we can do okay in some cases. And increasingly, we have much better outcomes with cancer, and we have much better outcomes with heart disease. But the best outcomes come from early detection and early intervention. That's just a truism in medicine. And there's no reason to assume that it would be any different for these disorders as well. That's a very different situation in terms of the kind of science we need to think about. That means we have to now be considering, can we develop diagnostics before somebody even has a symptom or has a major symptom? Is there a way to screen people when they're still functioning pretty well, but to know who we should be concerned about? And can we do this in a way that doesn't increase stigma, that doesn't put people at risk? Is there some way we can begin to think about these disorders along a dimension of development and to encourage the both detection and intervention of people who are in high risk, rather than waiting until people have gotten into a metabolic crisis? Now, the analog for this is probably a lot of the work that's going on today in schizophrenia. Now, that's a pretty interesting problem. It's we think now, a brain disorder. The symptoms don't usually start, the symptoms of psychosis don't start until about age 18 to 19. The average diagnosis in boys is about 19, girls about 21, 22. And if you look at that field, what's really changed over the last decade is the increasing recognition that psychosis is a late stage and that we could potentially intervene much earlier. We've actually had trouble with the language because schizophrenia has only been defined as the presence of psychosis, which would be like, defining ischemic heart disease by the presence of a heart attack. It's true, that is a stage in ischemic heart disease. But if that's when you make the diagnosis, you're probably too late to have the best outcome. And we've been thinking the same way about schizophrenia. So how do we identify this much earlier? Is there a biomarker? Is there some cognitive change? Is there some way of identifying risk with genetics that says, this is somebody who's on that trajectory? They don't need antipsychotic medication because that's been tried in Europe and it doesn't work. But what they do need is family support, involvement in the family in some really critical ways, perhaps cognitive support, that we're actually developing video games to help kids build resilience. So we think they can actually forestall or maybe even totally prevent the psychotic experience, to make sure that at least kids are able to finish school. A whole bunch of things that you can begin to do which are really hard to do after someone's had a psychotic event. But if you get to them early, you may be able to change the trajectory. Now, how that would happen for bulimia or anorexia, as we are talking about together, I'm not sure I know. But I'd love to have your best ideas about what might be the right way to go about that and how to identify who's at risk. And that brings me to my third point about the kind of new ideas that we're dealing with. So brain disorders, developmental approach, and the third is this idea of taking the power of genomics and now applying this for mental illnesses the same way we have applied this for cancer and hypertension and autoimmune diseases, Crohn's disease, illnesses like that. The Human Genome Project basically had its major terminus about a decade ago, in 2001. And at that point, Bill Clinton and Francis Collins and Craig Venter, the two scientists along with the president, got up in the White House and said, we now have a blueprint for human beings. And here it is, it's 3 billion bases of DNA, and this is the sequence. And it was an extraordinary moment. And in a sense, it was really worth celebrating, because this was the human genome in its entirety, almost entirety at that point. It was really completed a couple of years later. And it is 3 billion bases of text divided up across 26 chromosomes. You can think of those as chapters. And within each of those chapters, you have some thousands of genes that are important for making all the proteins that make us. The president's speech at the time was to say, this is going to give us now the blueprint for understanding human disease. And it didn't. And it didn't because what we had initially was a kind of consensus sequence. We had, the sequence for basically one person. And what we soon began to realize was that that text is different in every one of us. We're all a completely different book. We had no idea in 2001 how different we were from each other. But it became clear by 2004, or 2005, that about 1 million of those bases, about 0.1%, were variable between each of us, unless we have an identical twin, and in that case we don't have any differences in the sequence. This was kind of an exciting moment, because then people said, all right, now maybe we could use this to understand risk. And so there began a period in about 2006 when there was kind of a gold rush to try to understand how was the variation in the human genome associated with variation in human traits. Now, some of those traits were things like height, and some of them were susceptibility to cancer, and some were intelligence. And sometimes this worked really well, and sometimes it didn't work very well at all. It worked great for diabetes, asthma, Crohn's disease, inflammatory bowel disease, some forms of cancer, and hypertension to some extent. It didn't work so well for mental disorders, even though they were highly heritable. In the case of autism, schizophrenia, bipolar disorder, we actually didn't get very much initially. In about 2008, 2009, a very strange thing happened. As people were looking at the human genome in individuals who had these neurodevelopmental disorders, they discovered that those 1 million bases that change across each of us were not consistently different in a way that helped you to know who had schizophrenia and who didn't. But there was something else very strange. As they looked at this, they found that there were whole chunks, whole pages in the chapter that were duplicated or sometimes deleted. And this was kind of completely unexpected. We didn't even think this was compatible with life. Well, it is. In fact, we all have these. And these are large editing mistakes that happen in the genome, that basically you have a whole area and it could be not just 1 or 2 bases of the 3 billion, it's usually 1 million or 500,000 that are duplicated or quadruplicated or sometimes deleted on one strand. We call these copy number variations. We have, on average, we may have, each of us has 10, 15 of these, but in people who have these neurodevelopmental disorders, they have lots. They have them at a rate that's about, the big ones, about 10 times greater than those who don't have these disorders. And this gets really interesting. I know that there's a sensitivity in talking about the genetics of mental illness, because in some ways it conflates with this idea that of blame and shame that we have to get away from, that made up so much of the 20th century. So this gets amazing, because what it turns out is that even though this is genetic, most of these are not inherited. And we actually didn't even know there was a difference. We always thought that everything that was genetic was inherited from your parents. But this is something that these editing mistakes have seemed to appear in one of two ways. Either they occur very early in embryogenesis, in the first few cell divisions. We're not sure how much that happens, but that's one possibility. Or more likely, they're occurring in dad's sperm. So dad, a woman has all the eggs she's ever going to have at the time she's born. Dads have spermatogonia, they have germ cells that continue to divide throughout life. And father at age 20, a 20-year-old man, has had perhaps 10, 15 divisions of those spermatogonia. A man at age 40 has had about somewhere between 35 and 50 divisions. And it's in those divisions that editing mistakes can take place. And in fact, it's no accident that for many of the neurodevelopmental disorders, there's about a 5-fold greater risk for dads over 40 that they'll have an offspring with a child with epilepsy, autism, schizophrenia. I don't know if that's true for eating disorders as well. But this was an important insight for us. And I said, aha, so this is actually much more complicated than we thought. That genetics could turn out to be really intriguing for us in ways that nobody actually predicted. It's going to be very different than the genetics for cancer or genetics for hypertension. This is going to be about genetic changes that occur perhaps not in an inherited way, but are occurring across development or occurring across a father's lifespan. And the events may be multiple and they may be rare. And there may be many, many different ways to get many of these disorders. And that seems to be the case, that increasingly we're actually realizing that there are not 1 or 2 or 5 genes associated with schizophrenia or autism. There are at least 100. And we're not sure what they all are, we're not sure how they all work, but it's much more complicated than what we would have thought. Now, I harp on this a little bit to talk about the genetics because genetics has, as I said, it's changed everything in medicine. It's given us, for the first time, the ability to understand risk in a biological sense, in a very rigorous way. But it's also given us a way of understanding the biology of these illnesses by pointing us towards new targets. I just came from a 2-day meeting at the NIH, which is what I have to get back to, on how we're going to actually find a whole range of new targets for cancer by using genetics and using 100,000 subjects. And there's a very clear roadmap to do that. This one's going to be a little more complicated because here what we're talking about is trying to find something that probably works in development. It's probably not going to explain very many of people with anorexia or people with autism, and it could be rather rare. So the question for us is, how are we going to do this? How can we use this kind of very solid finding, which seems to be very real? These are big changes associated with these diseases. But how do we use those to understand something about the biology of the disease? They're not causative in the sense that sickle cell anemia or cystic fibrosis is caused by mutation, but they've got to be related in some way. And so we're trying to unpack that. And there's a new way to do that, which is changing, again, everything in medicine, which has to do with stem cells. And up until a couple of years ago, whenever people talked about stem cells, they meant embryonic stem cells, which was a huge political issue, and it was actually one of the very first things that the Bush administration, this is Bush 44, George W. Bush did when he came in, is to say no additional stem cell research or no additional stem cells. They fought that throughout that 8 years of Bush administration, and sometime towards the end of that term, a guy named Yamanaka from South Korea came up with an extraordinary discovery that you didn't need embryonic stem cells. You could actually take cells from an adult with a disorder, and these would be skin cells, fibroblasts, and you could treat them in a particular way that they would become like stem cells. They would be pluripotent, as the term, and then you could use those to create adult tissues. And so in any given individual who might have a rare mutation or maybe a common mutation, you could basically recreate a disease in a dish. And this has been done now in many areas, diabetes in particular, but also Parkinson's, many others. So this gives us a way forward. And we have just, I think today or Monday, we'll be funding the first study. Actually, it's to Walt's fellow, I think, in San Diego. to begin doing this for anorexia, taking fibroblasts from people with the disorder, creating stem cells, and trying to look at what happens when you grow various kinds of neurons or glia, or create small models of what's happening in the nervous system in addition. Highly theoretical whether this is going to work or not, but it's one way forward that has paid off in the rest of medicine. It's a great way to begin to screen for new medications. It's a great way to understand targets for developing new medications. And it's a great way to try to understand something about the biology. What makes these arrhythmias, these circuit differences happen, and how do they get coded for these, based on these very large mutations in the genome. So there's a lot going forward. I mentioned three things: the brain disorder concept, the idea that these are developmental, and then the third is the possibility of using genomics, and in this case we've mostly been talking about the DNA part of it. There's also a lot that can be done trying to understand how experience, either early experience or later experience, alters the way that text gets read out, and that's a whole area of epigenomics that is growing and giving us lots of new opportunities to ask different kinds of questions. Those three areas, though, I think are going to change the landscape for us going forward. Not this year, but over the next 5 years, there will be, we think, a real change in the way that we think about diagnosis, in the way we think about treatments, and I think maybe very importantly, in the way we have to think about our workforce. So before I finish, let me just quickly hit each of those, because I think the diagnosis, the treatments, and the workforce are all things that you need to be concerned about. In the same way that I said that we really limit ourselves by making the diagnosis dependent on what one could call late-stage symptoms, we are one of the only areas of medicine that continues to make all of diagnosis dependent on basically it's clinical consensus. You get a bunch of clinicians together in a room and you say, this is what I see, what you see. Once you agree, you say, all right, we've got a DSM category. That's actually not the way we diagnose most things in medicine. We usually have some sort of a physiological measure or a biomarker. It tends to be quantitative, and it often is multidimensional. So in the case of, you take your favorite disorder, rheumatoid arthritis, we've got lots of measures, some of which are symptom-based, some of which are based on the physical exam, some are based on laboratory exams. We put all that together, and there's a kind of menu of things that say you've got this kind of rheumatoid arthritis. The reason we got there in the rest of medicine is that it's pretty clear that symptoms themselves are not very good guides to underlying pathology. Think of chest pain or fever. I mean, those are indicators of a whole range of different kinds of causes, and they require different kinds of treatments. So, in a sense, we are living in a world where we're saying, what kind of chest pain do you have? And that'll get you someplace. It won't get you very far. I mean, it does help to be able to locate the chest pain and maybe to get the character of the chest pain in a particular way, but it doesn't tell you often if you're having a heart attack or whether you're having pleurisy or pneumonia. And those require very different interventions. They may all, by the way, require an analgesic, so you might get something for your pain. But if you're looking for something that's really a treatment for the underlying problem, you're not going to get there by just treating the pain. That's a problem for us, because that's what we've been locked into. So we've been trying to, again, redo diagnosis in a different way and create a diagnostic system that will include clinical presentation. Symptoms are important. Observations are critically important. But it will add into that, what do we know about brain circuitry, about genetic load, about family history, about lots of other things that could help us to tease apart disorders. Big thing that's happening in medicine, actually, the National Academy of Sciences released this report yesterday. The title is Precision Medicine. And the concept is, we used to talk about breast cancer, we don't use that term anymore. There are 6 different kinds of breast cancer, and we make the diagnosis based on a molecular signature, because each of them requires a completely different treatment. And the best outcomes come from identifying that signature and creating that treatment. That's where we need to go here. I don't know how many disorders are in the general rubric of eating disorders, but I don't think it's 2 or 3. I think there are lots. And one of the things we need to do is to begin to tease this apart so we can identify what are the different subtypes and who's going to respond to which treatment in the best way, and who's not going to respond to current treatments and needs new treatments, those kinds of issues. So that's diagnosis, which I think is going to undergo a major change in the next few years. If that doesn't sound like DSM-5, I'm sorry. But I don't think DSM-5 is going to be able to do this. It's really using the traditional clinical consensus approach. So we have this thing called Research Domain Criteria, or RDoC, which we've been talking a lot about through NIMH, and the hope is that RDoC will begin to transform the way we approach this. Not right away, but over maybe 2 to 4 years, something like that. Treatment. That is, again, going to be an area that's going to require a lot more innovation and focus. We have had virtually no innovation on the medication side for 4 decades, which is just egregious. I mean, that is completely unacceptable going forward. And it's a challenge because most of the pharmaceutical companies who had made medications in the past have now left this area to go into studying, to develop drugs for cancer and some immunologic diseases because they know where the targets are, they see a pathway forward. So this is a critical moment for us. We're going to have to figure out how to use the genetics and how to use what we know about these disorders to really come up with something that is tractable and that allows us to think about the next generation of medications. But there's no question that this is an area where non-medication therapies are going to continue to be important. And there is a great need for real innovation there as well. Now, this is one of the places where, and I'm not sure how well you appreciate this, that eating disorders is actually a great success story. From my perspective, or the NIMH perspective, when we go out and talk about where are the opportunities, or where are we seeing exciting things happen in treatments? This is one, because of what started at the Maudsley, the work that Jim Locke, who's here, I think, Jim, over here, and his colleague, Dale Grange, have done. It's just been extraordinary to be able to demonstrate how you can turn this thing on its head, and that everything that was being done for the last 3 or 4 decades of trying to get kids, especially kids, into longer and longer inpatient settings, further and further away from families. And if you reverse that, I thought I had actually invented the term parentectomy, but I think maybe I didn't. I think that might have come from someplace else. But if you can make sure that families become part of the solution rather than being considered the problem, you could get much better outcomes. How amazing, right? So I'm happy to say NIMH supported a good chunk of that work. The effect sizes are not small. They are really significant. So you're talking about 50% of people in recovery at 1 year. That is dynamite. I don't have data like that for autism. I don't have data like that for schizophrenia. I don't have data like that almost in any other disorder. That's extraordinary. Now, it's not the end, right? We need to make sure we've got equivalent results in adults. And we need to understand about the other 50%. So we need to really go after who isn't responding. How do we predict who's going to respond? And what do we do for that cohort of kids or adults? So there's a lot more to do here. And there are questions about, are there ways now to scale this up? Because I think a huge challenge for us in this era of technology and digital health or mobile health is how do we take this, which works great in Chicago and Palo Alto, and other centers, but make sure that it's available to everybody everywhere. And that is something that our institute is very interested in trying to figure out what's the best way to disseminate and to implement those programs that do seem to be most effective. What's great here is we've got something. I don't have this in a lot of other areas. Here we've really got something to work with. So there's a lot of excitement in our institute about how to take this to scale and how to make sure that we're saving a lot more lives because we've got a treatment that works. And isn't it amazing that that treatment actually is a treatment that essentially is all about family empowerment, family involvement, just what you're doing here. So we're on the same page. That's really great to see. And I think the part of why I made that comment to you a few years ago was that already we had the data there, and it's very clear that a lot of this can be driven by the community. And there's an opportunity to think about how to do this, how you can be part of making a really historic change in the way we treat these disorders. So we talked about diagnosis, treatment. Final thing is around training. And I also need your thoughts about this. I'm very concerned that almost everything that I've told you would be completely news to the 220,000 people in this country who are our clinical workforce. They don't get exposed to anything about the brain. They don't think of these as brain disorders. Many of them have no scientific training. And many of them wouldn't know about what is evidence-based and what isn't. Because what they do is what they were trained to do, sometimes 20, 25 years ago. That's, I think, worked okay in terms of supporting that profession. But it's not going to sustain them because in this new era of healthcare reform, people are going to start looking for accountability, and they're going to start looking for metrics and accreditation in different ways. And we're going to have to face this in a serious way fairly soon with questions about what should be paid for. Now, not so much through insurance, but even through whether it's Medicaid, Medicare, or through what will come out of the Affordable Care Act. There are going to be lots of issues around trying to demonstrate effectiveness and expecting people to be able to demonstrate that what they do and what's getting paid for actually is worth paying for. Part of this is going to be we're going to need to train a new cohort of people, and I think that we haven't even begun to consider that in a serious way. I've been talking a lot about the need to really perhaps create a whole new discipline, because I don't think the disciplines we have today are necessarily going to be able to embrace the kind of science that all of you need and all of your families need. So we can begin to think together about what that might look like. We've tried to use the logo of clinical neuroscience instead of talking about psychiatry or psychology or the current disciplines we have. And we're beginning to think with our colleagues in Britain, where they're very concerned about the same issue, about what will the new training look like, how do we create a new discipline in medicine. There's spectacular young people coming out of neuroscience programs across the United States in the best universities. They go to medical school because they're really interested in the brain and what it does, and they usually come out as plastic surgeons because they can make a lot of money. And is there a way to convince them that actually there's a pathway forward here? They get turned off by psychiatry because it does not have anything to do with the brain. And they get turned off by neurology because they can't see that they're really able to cure anything. So they end up going someplace where they can make a lot of money, which is perfectly understandable. What would make a lot more sense for all of us, I think, is because there's such a great unmet need here, is to figure out a way to get a whole new cohort of 1,000 or 2,000, maybe 10,000 people into this field who have a very different kind of training. And I think we can do that. I think that's where there's an opportunity to provide leadership and to provide some new pathways for students and even for people outside of medicine to get involved in some different ways. So that's a real quick rundown of the way that NIMH has been thinking recently about the major issues. The where the science is taking us is to think about brain disorders, developmental disorders, and to use the power of genomics to kind of get at the basic biology of these illnesses. And we are absolutely laser-like focused on these being biological illnesses. The short-term implications, I think, are going to be for the way we approach diagnosis, the way we try to come up with new ways of treatment, and then thinking about these larger problems of the workforce and training, and that's going to take longer, but that's one place we have to go. So I'm going to stop there, make sure we have some time for questions before we start the panel, and let me thank you for your attention.